section 1.4, measure and classify angles. So our goal in this section is to name, measure, and classify angles. So in order to talk about angles, we need to first identify what is an angle. An angle is simply two rays with a common endpoint. We measure an angle with a protractor. So for example, we have here an angle, and I have a protractor. There's always going to be a little hole or crosshair area that represents 0. And I'll make this a little larger here. And then we place that. And then what we do is when you are counting, you can see there's two sets of numbers, inside and outside. I use the set where 0 is. So for example, I'm going to the right here. Here is 0. And I use the outer numbers. So I'm going 10, 20, 30, 40. And this one appears to be about 44 degrees. I want to be as close as possible when measuring with a protractor. Now, if the angle was going the other way, or if I had it I was measuring for some reason like this, I would have, I can see I'm a little off 0, so I'd have to adjust it, but I'd be using the inside numbers because I want to start with wherever 0 is, not the 180. Alright, when we classify angles, there are 4 types of angles. The first one is acute. Acute is when the angle is between 0 and 90 degrees. This little symbol here, theta, represents angle, or we say angle measure. So theta, it's a Greek letter, theta is used for angle measure. When it's between 0 and 90, we say the angle is acute. A right angle is exactly 90 degrees. If it is 89.99999, it classifies as being acute because it is less than 90. When drawing a right angle, that is not a right angle. The only way we can tell it is a right angle is if we draw the right angle box. No box, no right angle. Next is obtuse. Obtuse is anything bigger than 90 degrees and less than 180. And you may see a line drawn like that to show the angle. But we're talking anything between 90 and 180. If it's 90, it's right. If it's 180, we say it is straight. Another name we use for a straight angle is a line. A straight angle is simply a line. The angle addition postulate is very similar to the segment addition postulate, just kind of changed for angles. So if P is in the interior of angle RST, so we're going to draw angle RST. And when we name angles, there are 2 ways to name them. We see here what's called the 3-letter technique, in which you name a point. The vertex is always in the middle, and then you have the point it goes to, so T. So if we have point P somewhere in the interior such that we have this ray connecting the vertex S through point P, what we can do is say that RST is the same as angle RSP, the smaller angle here. So this angle A, for example, and PST angle B here. An example being is if we were given that this angle is 30 degrees and this one is 40, we can say that angle RST equals 30 plus 40. So the measure of angle RST equals 70 degrees. This little M out front here represents measure. So if you're saying angle RST, up here we're not talking about any specific measure. So you're just going to say angle RST. As soon as you start throwing in numbers and are talking about the measure of the angle, we put that little M out front. Our next example says if the measure of angle ABC, pull that over here, enlarge it, is 172, find the measure of each of these two angles. So what we will do is say that these two angles, so 3x plus 6 plus 2x minus 9 equals 72. And if you wanted to go, you could say that angle ABD plus angle CBD equals angle CBA. And then start from there and go ahead and solve. So we're going to combine like terms. And we find that x equals 15. Again, this is the case where it says to find the measure of the angles. It does not say to solve for x. So we need to go through the extra work. So this is 3 times 15 plus 6. So the measure of angle ABD equals 51 degrees. Make sure you are labeling your answers. No labels is not going to equal full credit. You need to label your answers. On a quiz, if you just wrote 51, what's 51? I don't know what 51 is supposed to mean. And then, so we have, this one is 2 times 15 minus 9. So we have 30 minus 9. Measure of angle DBC equals 21 degrees. For those of you who like to check your answers, 51 plus 21 equals 72, which is what we saw in the original problem. That is a good thing. That is how you can check your work without having to go find an answer key or back the book or what have you. Congruent angles. Just like congruent segments, congruent angles have the same measure. We are going to do an activity with angle bisectors at the beginning of class. But we are going to define what is an angle bisector. An angle bisector divides an angle into two congruent angles. The word bi meaning two. If it was an angle trisector, it would divide an angle into three congruent angles. But it is a bisector, so it divides it into two angles. An angle measuring 122 degrees is bisected. Find the measure of a resulting angle. There are two types of problems with angle bisectors. You either have one where you are dividing by 2 or multiplying by 2. You just have to decide which case is it. in this case, we have an angle 122 degrees. If it's bisected, it's cut in half. So we are going to be taking 122 divided by 2. Or you could say it's half of 122. Either way, you get 61 degrees. So you are cutting the angle in this case. After an angle is bisected, the resulting angle is 61. What was the original angle? So this is a case where you know the angle is 61 degrees, but this is after. That means there's also another 61 degree angle. So this is going to be a case of taking 61 times 2 to get your 122 degree angle. Yes, I use the same numbers for both examples. You have to look carefully at the wording because it is very similar in both problems. You need to read carefully.